Here's how you establish the identity for problem number 16. First, I'll start by looking at deciding which is the more complicated side. The right-hand side, being made up of two fractions being added, is clearly more complicated. Now I'm going to look for any substitutions with my Pythagorean identities. If I look back at my Pythagorean identities here, they all have squares in them. A sine squared, a cosine squared, a 1 squared. If I look back at my two terms here, the fractions that are separated by addition, none of them have squares in them. So since I can't substitute any of those, I realize, okay, well I have two fractions being added, it has to become one term. So I might as well just add them. So I'm going to multiply, I'm going to find the GCF, which is cotangent of x, times cosecant of x plus 1, and I'm going to get both of my denominators to be that. So my first fraction, I'm going to have to multiply by cosecant of x plus 1 times cosecant of x plus 1. Now, one thing that's really important is that you realize this cosecant of x plus 1 has to be in parentheses because that's what it is. It's a cosecant of x plus 1. It needs to be brought together. So I'm also going to take the denominator of my second fraction and put it in parentheses so that when I multiply it by cotangent of x over cotangent of x, it's easily read as cosecant of x plus 1 times cotangent of x. All right, now I'm going to get my brand new fraction here. One big giant fraction, because remember, you're adding them. Might as well make it one fraction now. So my denominator is cotangent times cosecant of x plus 1. And my numerator is, I have to do 1 times cosecant of x plus 1, which is cosecant of x plus 1, plus cotangent of x times cotangent of x, which is cotangent squared of x. All right, so now what's jumping out to me is I just created a square. I have a cotangent squared now. I also have a 1. So I'm going to go back to my Pythagorean identities and see if there's anything substitutable here. All right, so what I notice right away is that I have a 1 plus cotangent squared of x, which is equal to cosecant squared of x. So I'm going to go back down to my problem here and say, all right, I have a 1 plus cotangent squared, which is substitutable with a cosecant squared of x. So that's going to be my next step is I'm going to write that's what I have. I have cosecant of x plus cosecant squared of x all over cotangent of x times cosecant of x plus 1. All right, so now what's jumping out at me is that my numerator is definitely factorable. There's a GCF of cosecant of x. If that's not jumping out at you, what you should be doing is looking at the fact that you're trying to get it to be secant. It's not even close. Secant's one fraction. Right now I have, in my numerator, there's addition. In my denominator, there's multiplication. I have something that needs to be simplified. In order to simplify this fraction or any fraction, I can only cancel out common factors. So I do have to factor. All right, so like we said before, my numerator is factorable. There's a GCF of cosecant. So I'm going to factor out a cosecant. I'm left with 1 plus cosecant of x. My denominator, cotangent of x, times cosecant of x plus 1. All right, so now what you should notice is that I do have a common factor. I have 1 plus cosecant of x and cosecant of x plus 1, which are the same thing. So now I have cosecant of x over cotangent of x. Now, I'm at the point where I realize I'm dividing two different terms, both of which can be rewritten as fractions. So now I'm going to write it out as cosecant of x divided by, using this division symbol, cotangent of x. I'm going to replace cosecant of x with 1 over sine of x. And I'm going to replace cotangent of x with cosine of x over sine of x. Now I realize I'm dividing by a fraction, and we don't divide by fractions, we multiply by the reciprocal. So I have 1 over sine of x times sine of x over cosine of x. I can simplify sine of x over sine of x. I'm left with 1 over cosine of x. And last but not least, we can simplify 1 over cosine of x to secant of x. If you look back at what you were trying to get, On the left-hand side, you are trying to get secant of x.